Right, so let's have a look at this type of question. It's from exercise 9M, and it gives us a graph of a function. And from this function, we have to draw the derivative f dash x. So that's the thing. So we've got the value of the function in red, and in green we'll draw the value of the function. So let me just put a y-axis below this in line and an x-axis. The thing is, we're not sure what the actual value of the function is, but we don't know if it's we don't know the exact positive or negative value, but we do know if it is positive or negative. So let's have a look at this point here. You see the gradient is positive here. It's going up at -1. So at -1, it's a positive value. Some sort of positive value. At -0.5, call that -0.5, it's got a maximum turning point. A maximum, that means the derivative at that point will be 0. So it's going to be at the 0 level. The derivative is 0 for that point there. It's possibly easier going straight to the stationary points, and on the x-axis, where there is a stationary point, on the x-axis, put a 0 position, because the derivative is 0 at stationary points. Remember, this is f dash x, which is the derivative, which is also the gradients. Now, if the gradients are 0, it's going to cross the x-axis at a 0 value. Gradients. Alright, there's no more turning points, there's only these 3. Now let's look at where the graph is positive. You see to the left of the first turning point, it's a positive gradient. That means it's going to be big positive, and they're getting smaller and smaller, more gently. So we've got big positives, and we're going to have some, it's going to work its way down to this 0 value. Okay, so now we've got some negative values, and here we got small negatives, and the gradients get bigger negative to the point of inflection. So smaller negatives. Now at the point of inflection, it's going to stop being so negative and start heading back to 0. So it's going to reach a big negative value here, and then it's going to start working its way back to 0. Here we've got small positives up to big small positives, and the slope is getting steeper, so small positives. Now we've got to get, at this point of inflection, it's going to start coming back to a 0 gradient. So we've got a big gradient here, and then it's going to start working its way back to 0. Now we're in the negatives, and it's going to go to a negative value. And notice this could be the degree 3 turning points could be an x to the power of 4, and it could have a negative because it's got a negative, and then etc. Alright, so it's going to have some ax4, bx cubed, etc. That's what that function could be. The derivative would be, if that's a power of 4, the derivative would be a cubic, so it's going to be some other coefficient of x cubed plus bx squared, etc. Notice how we're going down at the end, and here we're going down at the end. There's your cubic, just draw it, and that is the graph of your function. That's all you have to do. Well, I hope this has helped. Until next time, stay happy.